Okay, mean and standard deviation. This will be the first part of our statistics notes. We are going to spend this whole week on statistics. Every video and every day is going to be different. Each day there's going to be a homework that it's associated to that. So the first day is going to be mean and standard deviation. Tomorrow we're going to do normal distribution. I think you'll see. We'll get there. I don't know what it's going to be yet. I don't remember. But anyway, let's get started with mean and standard deviation. So you might have talked about this before. Mean is basically an average. To find an average, you add up all the values, all the numbers in your data set, and you divide by the number of values there were. Now, we, of course, know how to do that by hand, but to keep things nice and simple, we are going to just do everything with the calculator. We're going to find the mean with the calculator. We're going to find the standard deviation with the calculator and a whole lot of other things as well. We certainly can do them by hand, but because we're so crunched for time with the EUC coming up, we're just going to make sure that we handle the big points. So mean, as we know, is an average. Now, the big thing that I need you to remember, though, is the symbol for mean. Mean's symbol is X bar, which is an X with a line over it. So X bar is going to be the notation we use for mean, to mean average. So if a EOC or whatever ever asks you the question, what's X bar, you know that they're asking what's the mean. Okay. So, and then we talk about standard deviation. So standard deviation has another symbol that you need to know. Standard deviation symbol is this little O looking thing. It's technically sigma. It's kind of hard to do. It looks like a fancy guy with a hat. Anyway, what it is it's a measure of sort of the variation in the data set, how spread out the data set is. So again, we're going to let the calculator figure this out, but how it works is if you take any number in your data set and find the difference between that and the average, and you take the average of those differences, that is your standard deviation. So it's a measure of how distant the data points are, essentially, from your center. To keep it long story short. But anyway, it's basically a good way to measure how spread out some of your data points are. All right, so we'll let the calculator figure those things out as well as these. So we're going to create box plots. And to create a box plot, we need 5 very important values. The minimum, which is the smallest value, the first quartile, the median, the third quartile, and the maximum. And what this is essentially doing is it's breaking the data into fourths. So let's say you had 100 data points, right? So 100 data points, they're all, whatever. 100 data points. Then the minimum will be the smallest, the maximum will be the largest. The first quartile will be the first 25%. So, first quartile will be the first 25%. The second quartile will be the next 25%. The third quartile will be the next 25%. And, I didn't make this symmetrical, but the fourth quartile, which is the end, is the last 25%. I'll talk more about that once we draw a box plot to sort of emphasize the point a bit, but the calculator will find these numbers for us as well. So just to know what a box plot looks like, here's how we're going to draw them. We're going to draw them with a number line, and this number line will be, of course, very dependent on what type of values are in our data set, but it'll be a number line nonetheless. And then above the number line, we'll put the 5 components. So let's say our minimum was like 5, our first quartile was like 7, our median was like 12, our third quartile was like 15, and our maximum was 23. Let's say we calculated a problem and we got those values. Well, then on my number line at 5, I'll have a mark marking my minimum. At 7, I'll have a mark marking my first quartile. My median at 12, I'll have a mark there indicating my median. At my third quartile, which is 15, I'll have another mark there. And then at the maximum 23, I'll have another mark there. So I'll have 5 marks above my number line to indicate where all these things are. That's the minimum. That's my first quartile, my median, my third quartile, and my maximum. And how we sketch a box plot from this is we take the quarter 1, first quartile, and quarter 3, the third quartile, and that creates our box between quarter 1 to quarter 3. And inside that box, of course, we're kind of overlapping that median. So the box stretches from the quarter 1 to quarter 3. So this edge here is my quarter 1 value at 7, and this edge here is my quarter 3 value, or third quartile value at, 15? Right, and then inside it is our median. Now, the median does not have to be in the middle. The median could definitely be, a bit off-center, and most of the time it probably will be off-center. It's not necessarily always going to be in the middle, but it could be. And then, so the box is from quarter 1 to quarter 3, and then we have a whisker that connects the quarter 3 to the max and the quarter 1 to the minimum. So there's your box and whisker plot. Little box in the middle from quarter 1 to quarter 3, and then whiskers that stretch all the way out to your minimum and all the way out to your maximum. There's nothing else past the maximum, so there's no line or arrow going out from that. It just ends here. Same thing on the minimum side. Nothing goes past that. And that is your box and whisker plot right there. Now, to emphasize what this means, because everything's broken into quarters, let's again assume that I had 100 data points in this set. If there was 100 data points in this set, then that means that 25 of them would be in this range between 5 and 7. Let me go ahead and label this. 25 data values would be inside this region, a quarter of the data values. And 25 would also be within this region, from the first quartile to the median. It's breaking it into fourths. Right, so there'd be 25 in here, there'd be 25 in here, and there'd be 25 in here. So you think, oh, they're all even, they all have 25, so they would all have to be symmetrical, and you'd be wrong about that. No, box plots are not going to be symmetrical. Hardly ever will they actually be symmetrical. The reason for that is because the purpose of a box plot is to show us how spread out the data is. So for example, there are 25 values in this region here, and there are also the same number of values in this region here. All that tells us is that this region over here is more spread out than the one on the left. The one on the left, those 25 values are more condensed. They're all within 5 to 7, so they're very together. Whereas the one on this far end, the far right side, that region has the same number of data points, but it's more spread out. Those data points stretch from 15 to 23. So it's still 1/4 here, 1/4 here, 1/4 here, and 1/4 here. Still 25% each quadrant. But depending on the size of the quadrant will tell us how spread out the data points is. So a small region like this means that all the data points are really condensed, whereas if it's spread out a little longer, it's they're a bit more spaced out. Okay. Example 1. So let's make a box plot with this. So we're going to use our calculator. We're going to type these data points in, but let's read the problem first. A group of 6 automobiles was randomly selected, and the odometer reading was taken from each car. The number of miles on each is shown below. So 6 cars, and these are the miles for each car listed. Find the mean, the standard deviation of the set of data, and then create a box plot as well. So let's go ahead and do that. So I'm going to pull up my calculator real quick. I'm going to discard everything I already did. Pull my calculator. Here's how we're going to do this in the calculator. So to input these data points into the calculator, we are going to hit Stat, and we are going to Edit. And here we are going to input our list. Now, we don't need 2 lists. If you have anything here, you can just clear it. We only need to type this into list 1. So we're only going to put the 23,000, the 44,000, the 120,000, and so on. We don't have to put car 1, car 2, car 3. We don't need that in a list. We just need the mileage. So 23,000, 44,000, 120,000. Oops, make sure you type it in properly. 0, 0, 0, 0. 31,000. 27,000. 19. All right. So we got all the data points there. Now, to get all the information, the mean, the standard deviation, and then the minimum, first quartile, all that stuff from my box plot and everything, we're going to go to Stat again, but we're going to go to Calc, And one var stats is where all the information we're looking for is. So we go one var stats, make sure you see it's using list one because that's just where I put my data. My data is in list one. We shouldn't have to touch that. Should be fine. You can leave it alone. And then calculate. So here we go. You can see, remember x bar is the mean. So you can see on the calculator that x bar is 44,000. So my mean x bar is 44,000. Now it's a little bit interesting, and I didn't mention this already, but in the calculator, SX, oops, hold on, let me go back. Can I make this a little bit bigger? All right, just so you can see it better. So you see the fourth thing down, SX is actually the standard deviation, where the sigma, or the little Greek letter I mentioned earlier, that's actually, I believe, the variance here. That's not the actual standard deviation. The calculator, the standard deviation is SX. So why they make that distinguishment, I'm not 100% sure. But just be aware of that, because I told you that symbol meant standard deviation, and it does. But in this calculator, we kind of actually ignore that symbol, and we look at SX. SX is our standard deviation. So in this case, it's 38,209.9. So our standard deviation, 38,209.9. So now we've got the mean standard deviation. That's good and all, but now we've got to make a box plot. So we don't actually need that information to make a box plot. We're just going to make a box plot. To make a box plot, we need the minimum, we need the first quartile, we need the median, the third quartile, and the max. And thankfully, on this calculator, if we scroll down just a little bit, all of those numbers are right there. So you can see the minimum, 19,000, first quartile, 23,000, median, 29,000, third quartile, 44,000, and the maximum, 120,000. So with that in mind, I'm going to make a box plot. So let me go ahead and full screen this real quick. I'm going to do it up here. So let me make a number line. And I'm just going to sketch this out real quick. So I'm not going to make it like as neat as it probably should be, but that's fine. So our minimum was 19,000. So we'll just say this is 19,000. Our first quartile was 23,000. Our median was 29,000. Our third quartile was 44,000. And then our maximum is actually way further out. That's going to get in the way. Our maximum is 120,000. So it's actually really far away from the rest of these. So anyway, let's sketch our box plot. So I'm going to put a little tick mark for each of these, right? So remember, this first one is for the minimum. Then you've got the first quartile, the median, third quartile, and the maximum. So you have 5 data points. Remember, the box part goes from the first quartile to the third quartile. So putting a box around those tick marks. So the edge of this box is my quarter 1. And the edge over here is my quarter 3. And then the median is that line somewhere inside that box. And then the whiskers will connect the edges together. And there's your box and whisker plot. Okay. So there are a few other examples that you'd work out exactly the same way. I'm not going to here because I just want to keep the video nice and short and sweet for you. So you do the exact same thing we just did. You input these values in the calculator. You go to your one var stats. It'll tell you everything you need. And then make sure when you make your box plot, you find your 5 values, your minimum, your first quartile, your median, your third quartile, and your maximum, right? And then create the box around all those data points. So the box goes from quarter 1 to quarter 3, and then the whiskers go to the minimum and to the maximum, connecting this all together. All right, that's going to be it. The next video, we will talk about normal distribution.